Hey guys, welcome. This is our Chapter 2 study guide. Let's get started. So these are all the properties. So make sure you have that property list
Excuse me, Mr.
or
Smith.
vocab list. 1 second. Okay, so sorry, where we are. XY equals LM, LM equals PQ, XY equals PQ. So if we follow this pattern here, we see the XY there twice, we see LM here twice, and then we see PQ. And what it's saying, it's like, hey, if XY equals LM and LM equals PQ, then these should equal to each other. That would be our transitive property. Here we are saying measure of ABC equals measure of ABC. That's just reflexive property. They're the exact same. Here we have to go from 1/8 x equals 20 to x equals 180, so we can multiply both sides by 8. That would give us x equals 160, so that's multiplication property. AB equals EF, EF equals AB, so a lot of kids will think this is reflexive property like number 2, but number 2 it's the exact same thing. Here these aren't the exact same, but they flip them. So that's an example of symmetric property. Here we're distributing the 3 to get this, so that's distributive property. And then here we're saying x equals 5, and then x plus y equals 30, and then all of a sudden we get the x is no longer there, but it's 5. So that's an example of substitution property. What type of reasoning do you use, and what is the next item in the pattern? So whenever we're looking at patterns, we're talking about inductive reasoning. Inductive reasoning is reasoning based upon patterns. Deductive reasoning is using facts. Okay, so it looks like we're going multiples of 3, multiplying by 3, but then maybe we're multiplying by -3 each time. So 27 times 3 is 81, but this one should be a -81. Which is a counterexample that shows the following statement is false. If B is between A and C, then AB always equals BC. Well, you could just draw a picture here of A, C, and B is right here, and you could just say, well, hey, if this is 2 units long, then this is 8 units long. They're definitely not congruent. AB is not equal to BC. Again, between doesn't mean it's in the middle, it just means it's somewhere in there. Determine if a valid conclusion can be reached from the 2 true statements using the law of detachment or a syllogism. Okay, so it says beach towns are busy during the summer. So if we put this in the if-then statement, it would be if you're a beach town, then you're busy during the summer. So this is P, then Q. San Clemente is a beach town. So we really want these 2 statements to line up, which they do. And if that's true, then we can conclude the Q. So again, detachment was P, then Q. If P is true, then Q is true. And again, the key is to match those P's up. So what can we say? You can say San Clemente will be busy during the summer. On the go formative, if you're filling this out on the go formative, don't worry if it marks you wrong, as long as you said something along those lines, you're fine. Grumpy people are not fun to be around. So you could say if you're grumpy, then you're not fun to be around. If you're grumpy, then you won't have a lot of friends. So how would we write that? Well, if grumpy would be P, then you're not fun, that's Q. If you're grumpy, that's P again, because we already had P, and then you won't have a lot of friends, R. So this gets really close to following the pattern of law of syllogism, but law of syllogism is P then Q, Q then R. And then, therefore, we can say P then R. So this actually doesn't follow it, so it's no conclusion. And this one said state the law, and the law was detachment here for the first one. Puppies love to chew furniture. So we could say, if you're a puppy, then you love to chew furniture. So P, puppy, Q, furniture. Okay? So if you're a puppy, does that match with you chew furniture? Nope. So that is no conclusion. Okay, you could be a baby, I guess? I don't know. Running a marathon will make you tired. So if you run a marathon, then you will be tired. So P, running a marathon, being tired, Q. If you're tired, Q, then you need a lot of sleep, R. So this actually does follow our pattern, right? So we have P here, and we really want that R to be the conclusion of the first one and the hypothesis of the second one, so it's used twice. And then we have our third new statement. So now we can compare, run these and say, if running a marathon, then you need a lot of sleep. So that connects the P and then the R. All right, so given the statement, write the conditional. So we can write if a driver, then 16 or over. Okay, so there's my P, then Q. I'm going to just go yellow and pink for P and Q. Okay, identify the hypothesis. That would be a driver. And the conclusion, 16 or over. Again, on the go formative, as long as this is basically what you're writing, don't be mad if it marks you wrong. The converse would be to flip them. So we're going to say if 16 are over, then driver. And that's actually not true because you could be 18 and not have a driver's license. So that's false. The inverse, so again, this one flipped the P and the Q. The inverse does not. Alright, so for the inverse, we don't flip them, so we'll just say if not a driver, then not 16 or over. So the key is that we have the word not in here, but the order remains the same. Okay? So is this true? If you're not a driver, then you're not over 16. And that's not true. Again, you could be 18 and not drive. Then contrapositive, you're going to do flip and say not. So if not 16 are over, then not a driver. So again, keyword not, and we have the orange, pink in front now and the yellow in the back. So if you're not over 16, then you're not a driver. That's actually true because you have to be 16 over to be a driver. So that's actually true. Counterexample to the converse statement. Again, they'll probably mark you wrong on a thing, but a converse, like this kind of counterexample would be like if you're 16 or over, then you're a driver. You could be 18, no driver's license. Okay. Okay, this next one here is referring to a diagram. Ooh, we have an ant. Got it. So 1 is 2x minus 5, and 3 is 4x minus 45. So these are congruent because they're vertical angles, so we can just set them equal to each other. So I'm going to subtract the 2x, and we get negative 5 equals negative 45 plus 2x. Okay, so then we're going to add the 45 over here. So we get, let's continue this question over here. 2x on that side and 40 on this side. Divide by 2, get x equals 20. So we got to find angle measure 2. So I got to plug it back in here. So 2 times 20 minus 5, that's going to be 40 minus 5. So that's 35 degrees is angle 1. Well, angle 1 and 2 add to 180, right? So angle 1 plus angle 2 add to 180 because they're supplementary. And so this is 35 plus angle 2 equals 180. So subtract 35 and angle 2 equals 145. And then same question, 2 and 3 are these. Find angle 1. So 2 and 3 are a linear pair, so we're going to add those and set it equal. minus 2.5, so that's the 2, but then we're going to add angle 3 because this is a linear pair, or supplementary if you will, and they should add up to 180. So we're going to combine like terms to get 3.7 plus 5.8, which gives me 9.5x, and then negative 2.5 and 10.2 is going to give me positive 7.7 equals 180. So I'm going to subtract the 7.7 from 180. Again, I'm using a calculator. I highly recommend you do as well. We get 172.3 equals 9.5x, and then divide by 9.5. And we're going to get like a long decimal here by about 18.1. Then we want to find angle 1, and to do that we have to plug it back into angle 2 and then kind of do what we did up here. Or actually it's just equal to angle 3, so let's just plug it in for 3. That'd be much easier. So, because 3 and 1 are congruent. So angle 3 is 5.8 times 18.1, that's x. That's our substitution right there. And so we're going to multiply that by 5.8 and then add 10.2. I'm just doing it on my calculator. And so angle 3 equals 115.39. So that means angle 1 must also be 115.39. We made sure we found the same thing. Again, 1 and 3 are vertical angles, so that's how I knew they were congruent. And 2 and 3, right? 2 and 3 were 180 degrees. That's how I knew to set it to 180. All right, 2 proofs, and we're good to go. So the first thing, this is just an algebraic proof, so sometimes the easiest is just to do the algebra, but we're going to multiply by 5. That's the first thing you should always do. That cancels that, so we get 8x minus 3 equals 40. Well, I just multiplied both sides, so that's going to be multiplication property. Here, I'll add the 3 over, and so that's 8x equals 43. That should be a 45, I apologize. So that's 48. Okay, then we can divide by 8. Oh, sorry, so I added 3 to both sides, so that's addition property. And then divide by 8 on both sides, and we should get 6. And we always want to make sure our last one is that. So x equals 6, and that was division property. So you will have one algebraic proof on there. You also have a geometric proof like this one. So here our key is, it says the word bisector right here, and that tells me that this is equal to this. So you have to know your definitions. So the first one, it says CAB, which is this top angle, and BAD are congruent, and that's because, well, it's what we just said, definition of a bisector. Then it goes from congruency to equality. That was a mistake there. And then I go from the measure to this value, and that's substitution property. And then here we distribute, so that's distributive property. And then next we have 2 steps to finish this off. We know the last step has to be x equals 9. So I have to subtract the 5x, but I'm going to also subtract the 2 at the same time. So I'm going to end up with 2x equals 18. And since we did subtraction, we need subtraction property. And then we're going to divide both sides by 2 to get x equals 9, so that's division property. And that's the proof. Alright guys, hope that helped. We'll catch you on the flip.